Everything you are is a gift from the sun. Take a breath. The oxygen filling your lungs was breathed out by a leaf, by a world of green plankton, all turning their faces toward a star 93 million miles away. Think about the food you ate today. The wheat for the bread, the grass that fed the cattle, the algae eaten by the fish. Every chain of energy, every link, begins in that same distant thermonuclear fire. The energy thrumming in your muscles as you walk, the electricity firing in your brain as you listen to these words, is all just borrowed sunlight, captured and packaged moments, days or years ago. For all of human history, and for all of life's history, this has been the one indisputable truth. The sun is the cosmic deity, the source, the engine of all life. It is the generous hand that separates our living, breathing world from the cold, sterile silence of a planet like Mars. This process, photosynthesis, is not just a chemical reaction. It is an ancient spell, a green miracle that turns light, water, and air into life itself. It is the foundation of 99.9% of all biomass on Earth. This is the law. All life must eat, and all food ultimately comes from the sun. This is the law, and we were wrong. We were profoundly, fundamentally wrong. Because there is a place on our own planet where this law has no meaning. A place our star has never touched, and never will. It is a realm not of days and nights, but of eternal midnight. A world so alien it may as well be on another planet. It is a place of such immense, crushing pressure that it would powder our bones to dust in an instant. A world of near-freezing cold, a silent, geological tomb. We are talking about the deep ocean, the abyss. Go down. Leave the bright, sun-drenched surface. Past 200 meters, where the last faint photons of blue light are extinguished. Past 1,000 meters, the midnight zone, where the darkness is absolute, a physical weight. Keep going. Deeper. 2,000 meters. 3,000. The pressure is now hundreds of times greater than at the surface, a force equal to laying an elephant on your thumb. The water is a barely above freezing 2 degrees Celsius. According to the one great law of biology, this place should be a desert. And for decades we believed it was. We believed it was a vast, barren expanse of mud, sparsely populated by ghostly, slow-moving scavengers, creatures of profound patience, waiting for the dead to rain down from the world of light far, far above. It was a world of endings, not beginnings. But in this eternal night, 2 miles beneath the waves, there are oases. Not just life, but ecosystems. Crowded, dense, vibrant cities of life. Forests of towering, alien creatures. Fields of giant mussels and pale, blind crabs, all teeming in the dark. It is an impossible garden, blooming in a place where no light has ever shone. This discovery presents the single greatest paradox in modern biology. If the sun is not feeding them, what is? What power is fueling this impossible abundance? What God has replaced the sun in the heart of the abyss? The answer would not just reveal a new animal. It would reveal an entirely new way to live. It would force us to rewrite the definition of life itself. And in doing so, it would open a dark window to the most profound question we can ask. Are we alone in the universe? The story begins in a place that should be dead. Before 1977, the deep ocean floor was a subject of logical assumption. Biologists were not fools. They knew life existed down there. They had dredged it up. Strange, translucent fish with expandable stomachs, brittle stars with spindly arms, and burrowing worms that sifted the mud. But all of it conformed to the one great law. It was all part of the sun's extended empire. The energy model was simple, and it was called marine snow. Imagine the sunlit surface of the ocean, the photic zone. It is a vibrant, chaotic jungle of microscopic life. Plankton, phytoplankton, the grass of the sea, bloom and die. Zooplankton, the insects, eat them and are eaten in turn. Fish, whales, sharks. The entire surface world is a frantic cycle of life and death. And when anything in this world dies, a single-celled alga, a microscopic crustacean, a fish, or even a whale, it begins a long, slow journey down. This constant, gentle, silent rain of organic detritus is the marine snow. It is a funeral blizzard, a cascade of dust, fecal pellets, scales, and corpses, drifting from the bright, noisy banquet above into the silent, dark cellar of the world. For the life in the abyss, this was believed to be the only food source. They were the ultimate scavengers, living on the crumbs that fell from the table of the sun. But this is a system of profound inefficiency. The journey is long. A particle of marine snow can take weeks, even months, to fall 2 or 3 miles to the seafloor. On its way down, it is consumed. Bacteria feast on it, breaking it down, using up its energy. Smaller creatures in the midwater intercept it. The ocean itself levies attacks on everything that falls. By the time this snow reaches the abyssal plain, it is no longer food. It is energetic dust. It is the faintest whisper of the life it once was. The amount of energy that actually reaches the bottom is a tiny, tiny fraction of what was created at the surface. And a low-energy system can only support a low-energy biology. This is why scientists knew what they would find. A desert, a few scattered organisms, living lives of incredible slowness. Creatures that might feed once a year, that move with geological patience, that have traded complexity for sheer, frugal survival. The dominant feature of the deep sea was supposed to be mud. Just endless, cold, dark mud. Occasionally a jackpot would arrive. A whale fall, the massive carcass of a great whale, sinking to the seafloor, would deliver a sudden, enormous bounty of energy. This, scientists reasoned, would create a temporary oasis. A flurry of activity as sleeper cells of scavengers, hagfish, sleeper sharks, giant isopods, awoke and swarmed the body. But this event was rare, localized, and still ultimately part of the sun's food chain. It was an exception that proved the rule. So, when the deep-sea submersible Alvin was prepared for a dive in 1977, the biologists on board were not expecting to find a new world. They were, in fact, not the primary mission. The mission was geology. They were there to study the Galapagos Rift, a place where the Earth's tectonic plates were pulling apart. They were hunting for hydrothermal. Their expectations for biology were quite reasonably near zero. The seafloor here was new volcanic rock. It was a geological construction site, not a nursery. It was the last place on Earth you would expect to find a thriving, dense community of life. The consensus was clear. The deep ocean is a barren wasteland, a world of scavengers surviving on the scraps of the sun. Life could exist there, but it could never thrive there. The sun was too far away. The abyss was too cold, too dark, and too hungry. The Alvin closed its hatch, the ballast tanks filled, and the small 3-person craft began its 2.5-hour descent, sinking away from the world of light and into the greatest biological shock of the 20th century. The world inside the Alvin submersible was cramped, cold, and dark, save for the glow of instruments. The 3 men inside, 2 pilots and 1 scientist, were encased in a 7-foot titanium sphere, their only view of the outside world through 3 tiny, thick glass portholes. Outside, the pressure was a bone-crushing 250 atmospheres. They were descending to 2,500 meters, a mile and a half down. Their mission was to find geological proof of plate tectonics. The theory predicted that as the plates spread apart, seawater would seep into the cracks, be heated by magma, and then vent back out. They were towing a temperature probe, Angus, hoping to find a small anomaly, a slight increase of a few tenths of a degree, indicating a leaky patch of seafloor. On February 15, 1977, Angus's instruments suddenly went haywire. The temperature didn't just rise by a tenth of a degree. It spiked. The data was so strange the scientists thought the equipment was broken. 2 days later, Alvin descended to the same spot to see for itself. Peering through the portholes, the team navigated across a bleak landscape of fresh, black volcanic rock. It was, as expected, a desert. And then, they saw them, shimmering water. In the pitch-black darkness, illuminated only by Alvin's powerful floodlights, the water itself seemed to be dancing. It was venting from cracks in the seafloor, a clear, warm fluid in the near-freezing dark, creating a strange, watery mirage. But this was not the main event. They pressed on, and they found the black smokers. They were chimneys, towers, some standing 30 feet tall, like Gothic cathedrals of pure mineral. And from their spires, they were belching a thick, roiling jet-black plume of superheated water. This was not just warm. The team's probes measured the temperature, 350 degrees Celsius, hot enough to melt lead. It was water so hot, it was only kept from boiling by the colossal, crushing pressure of the deep sea. The water was black because it was a toxic soup. As it passed through the Earth's crust, it was stripped of oxygen and magnesium and became saturated with metals, iron, copper, zinc. And, most importantly, it was infused with a chemical that is a deadly poison to almost all life we know, hydrogen sulfide. The unmistakable smell of rotten eggs. The geologists were ecstatic. This was the discovery of a lifetime, a direct view into the planet's molten heart, a process of planetary creation happening right before their eyes. But the real shock, the one that would change biology forever, was around the vents. The dead volcanic rock was not dead. It was covered in life. Not the sparse, slow-moving scavengers they expected, but a dense, teeming, vibrant metropolis. The geologists, bewildered, began describing what they saw over the radio to the surface ship. They described fields of giant mussels the size of dinner plates. They saw swarms of pale, eyeless crabs, scuttling over the rocks, apparently unharmed by the toxic water. They saw strange, dandelion-like creatures anchored to the stone. And most bizarre of all, they saw a forest, a dense thicket of white tubes, rooted to the rock, and from the top of each tube, a brilliant, blood-red plume waved like a flower in the current. They were giant. This was not an ecosystem. This was a biological impossibility. On the surface, the biologists listening to this radio feed were in disbelief. They told the geologists they must be mistaken. They must be seeing trash or strange rock formations. There was nothing in the textbooks, nothing in the great law of the sun, that could account for this. This was a teeming, complex ecosystem, with a massive biomass, thriving in total darkness, at extreme pressure, in a bath of lethal poison and heavy metals, fueled by water hot enough to melt lead. It was a world that could not exist. When Alvin returned to the surface, its collection basket was filled with specimens of these impossible creatures. The biologists on deck were confronted with the physical proof that everything they believed about the limits of life was wrong. These creatures had no connection to the sun. The marine snow here was irrelevant, buried under the sheer, overwhelming abundance of this new community. This was not a world of scavengers. It was a world of producers. A new food web was being created right here in the dark. But how? What was the sun of this dark world? The answer was not in the sky. It was in the smoke. It was the poison itself. The discovery of the vents created a crisis in biology. The law was broken. The energy had to be coming from somewhere. It wasn't light. It wasn't the rain of the dead. The only new thing at the vents was the geology itself, the heat, and the chemicals. The heat was too chaotic, too destructive. The answer had to be the chemicals. Specifically, that one toxic chemical, hydrogen sulfide, $H_2S. To us, hydrogen sulfide is a poison because it attacks a critical enzyme in our cells, shutting down our ability to use oxygen. It is a fast-acting and lethal agent of suffocation. To the creatures at the vents, however, it was something else entirely. It was food. Scientists discovered that the true foundation of this entire ecosystem was invisible. It wasn't the giant tube worms or the mussels. It was bacteria, archaea to be precise, an ancient form of life that is fundamentally different from all plants and animals. These microbes were thriving in the shimmering water, the boundary layer where the 350-degree, sulfide-rich vent water crashed into the 2-degree, oxygen-rich seawater. And these microbes were doing something magical. They were performing a metabolic miracle, a dark parallel to photosynthesis. We call it chemosynthesis. Let's break down the logic. Life needs energy to build itself. Photosynthesis, light synthesis, uses the energy of a photon, a particle of light, to power a factory. The factory takes carbon dioxide, $CO_2, and water, $H_20, and builds them into a sugar molecule. This sugar is the battery. It is the chemical energy that powers the plant and every animal that eats the plant. Oxygen is its waste product. Chemosynthesis, chemical synthesis, follows the exact same logic, but uses a different power source. Instead of a photon of light, the bacteria use the chemical energy stored in the bonds of the hydrogen sulfide molecule. They seize the $H_2s molecule and break it apart. They oxidize it. This reaction releases a burst of energy. The bacteria then harness that exact energy to run the exact same factory. They take $CO_2, which is plentiful in the deep sea, and build it into a sugar molecule. It is a complete, independent primary production of food. The sun, for this world, is not a star. It is the internal geothermal heat of the planet Earth. The planet's core is cooking the rock is infusing the water with chemicals, and the bacteria are eating those chemicals. They are, in effect, eating the Earth itself. This is the other life process, a shadow biosphere that had been operating on our planet for potentially billions of years, completely unknown to the surface world. The crabs were eating the bacteria. The mussels were filtering the bacteria from the water. The food chain was complete. The bacteria were the plankton of the abyss, the grass of the deep. They were the producers, creating new energy, new life in total darkness. This discovery was staggering. It meant that life was not a slave to the sun. Life was a slave to energy, and it would take energy wherever it could find it. If it couldn't get light, it would find a chemical. If it couldn't find oxygen, it would breathe sulfur. This new, dark engine was fueling the entire oasis. But it still left one colossal mystery. The star of the show. That 8-foot-tall, blood-red creature. The giant tube worm. When scientists brought it to the surface and dissected it, the mystery only deepened. What they found inside it was so strange, so unprecedented, that it looked less like an animal and more like a piece of alien technology. The creature was a living paradox, and it held the key to understanding this entire, brave new world. It was the animal that had forgotten how to eat. The creature was given a name, Riftia pachyptila, the giant tube worm. The first thing scientists noticed when examining it was what it lacked. They searched the beautiful scarlet plume for a mouth. There was none. They looked for a pathway, a pharynx, a stomach, an intestine, an anus. There was no digestive system at all. This is a biological impossibility for an animal. An animal, by definition, is a creature that eats other organisms. It must ingest, digest, and excrete. This giant, complex, fast-growing animal, some grow as much as 30 inches a year, did not have the most basic machinery for being an animal. So how was it alive? How was it thriving? The answer was not on the worm or around the worm. The answer was inside the worm. When they cut the thick, white, leathery tube, they found the animal's body. And the vast majority of that body was not muscle or nerves or reproductive organs. It was a single, massive, spongy organ that they had never seen before. They called it the trophosome. And the trophosome was filled with bacteria. It was not an infection. It was a farm. The worm's body, which constituted half its weight, was a living, breathing bioreactor, densely packed with trillions of the very same chemosynthetic bacteria that lived free in the water. This was the solution to the paradox. The worm had not forgotten how to eat. It had transcended eating. It had formed the most intimate, a most absolute alliance with another life form. It had outsourced its feeding to a tenant living inside its own body. This is how the system works. It is one of the most elegant and bizarre mechanisms in all of biology. First, the gills. That beautiful scarlet plume is not just for show. It is the worm's interface with its world. It is, in effect, its mouth, its lungs, and its solar panel all in one. The plume is bright red because it is engorged with a specialized and unique form of hemoglobin. This blood, is a miracle of biochemical engineering. The plume filters the water, absorbing three things: oxygen, $O_2, from the cold, ambient seawater; carbon dioxide, $CO_2, dissolved everywhere; and, from the hot vent fluid, the deadly poison, hydrogen sulfide, $H_2S. Now, here is the problem. $H_2S and $O_2 are highly reactive. In the presence of oxygen, hydrogen sulfide breaks down, and it's also, as we've noted, lethal to the worm's own cells. The worm needs to transport both at the same time through its body to its internal farm. Its unique blood is the solution. The hemoglobin molecule has separate binding sites. It's a molecular delivery truck with different cages. It grabs the oxygen in one cage, and it grabs the hydrogen sulfide in another, holding them both safely and separately so they cannot react and poison the worm. This loaded blood then flows down from the plume, deep into the worm's body cavity, into that massive organ, the trophosome. And there, it delivers its cargo. It hands the bacteria everything they need to live. It gives them the sunlight, the $H_2S, the air, the $CO_2, and the oxygen, the $O_2. The bacteria, safe inside their living host, do what they do best. They perform chemosynthesis. They break the sulfide, harness the energy, and build sugars. And then, they feed their host. They create so much organic carbon, so much food, that they leak it directly into the worm's bloodstream. The worm is bathed in a constant, rich internal supply of nutrients 24 hours a day. It is being fed from the inside out. It is an obligate symbiotic relationship. The bacteria cannot survive the harsh, open water of the vent field. The worm provides them a safe, stable home and a perfect delivery service for their raw materials. The worm, in turn, has no way to feed itself. It is completely 100% dependent on the food its internal partners create. They are not two separate organisms anymore. They are one, a composite being, half animal, half bacteria, a true chemosynthetic animal. It is a farmer that has become its own farm. It is a mouth that has become a lung for a different kingdom of life. It is an impossible creature, a living testament to a dark, new biology, a life built not on light, but on the chemical breath. The discovery of chemosynthesis, and the impossible animal it supports, was more than just a new chapter in biology textbooks. It was a complete paradigm shift. It was as if we had spent our entire history believing fire was the only source of heat, and then one day we discovered electricity. Before Riftia, the rule was simple: life equals water plus sunlight. After Riftia, the rule was shattered and rebuilt: life equals liquid water plus an energy gradient. \energy gradient is the key. It just means a source of energy. Sunlight is one. The chemical-rich water from a hydrothermal vent is another. This realization fundamentally and dramatically expanded our definition of a habitable environment. Suddenly, the dark, cold places of the... For decades, we had been searching for life out there by looking for planets like in here. We were looking for Goldilocks planets. Not too hot, not too cold, orbiting a friendly star at the perfect distance for liquid water to exist on its surface. We were, in effect, looking for a second Earth, a second sunlit world. The deep-sea vents told us we were looking in the wrong places. Or, at least, Riftia and its ecosystem proved, definitively, that you can have a complex, dense, thriving biosphere in total darkness, under crushing pressure, in extreme temperatures, fueled entirely by energy coming from a planet's interior. Life does not need a star. It just needs a living planet, a world that is geologically active. And this changes everything. Let us leave Earth, travel 485 million miles out, to the largest planet in our solar system, Jupiter, and let us look at its fourth largest moon, Europa. Europa is an ice world. Its surface is a cracked, frozen wasteland, bombarded by radiation, with temperatures of -160 degrees Celsius. It is a world without sunlight, a tiny fraction of what we receive. By all the old rules, it is a sterile, dead moon. But we know from a wealth of data that beneath that 15-mile thick crust of ice, there is an ocean. A global liquid water ocean that is twice the volume of all the oceans on Earth combined. It is dark. It is under pressure. But is it alive? For a long time we thought no. Without sunlight there is no energy. But now we ask a different question. Is Europa geologically active? We believe it is. As it orbits Jupiter, the colossal gravity of the giant planet needs the moon, stretching and squeezing it. This tidal friction heats Europa's rocky core, just as magma heats Earth's crust. So, on the dark seafloor of Europa, 60 miles beneath the ice, in an ocean of total blackness, are there hydrothermal vents? Are there black smokers gushing chemical-rich water, heated by the planet's core? And if there are there bacteria, archaea performing chemosynthesis? And if there are there larger, more complex composite creatures? Are there Europan tubeworms harvesting this energy? Is there an entire complex biosphere that has lived and died and evolved for 4 billion years, in total magnificent isolation, having never once seen the sun? We no longer have to guess. We have a blueprint. Riftia is our proof of concept. Or look to Saturn's moon, Enceladus, another small, ice-covered world. We know it is active. In 2005, the Cassini probe flew through geysers, plumes of water, erupting from cracks in its south pole. It sampled that water, and it found salt, silica, and, critically, hydrogen molecules. It found chemical fuel. It found all the ingredients for chemosynthesis. The discovery of the Riftia tubeworm did not just introduce us to a new animal. It introduced us to a new hope. It gave us a new map for the search for life. It told us that the most likely place to find our neighbors in the universe is not on the bright, sunny surfaces of worlds like our own, but in the deep, dark, hidden oceans of worlds we once dismissed as cold and dead. Life is more tenacious, more creative, and more alien than we ever dared to imagine. The most profound, the most extraterrestrial life we have ever encountered was not in the stars. It was right here on our own planet, in an eternal darkness, patiently waiting to show us how little we truly knew about the nature of life itself. It is the chemosynthetic animal, the creature that does not need the sun. And it is a beacon, pointing us toward the dark, hidden oases that may, right now, be thriving in the silence of our own solar system.